Hey everybody, today we're going to do Triangle Properties 5, which to me is the easiest lesson of the unit. I know teachers aren't supposed to say something is easy, because then if a kid finds it hard, they're going to not feel so great about it, but just work with me here. I assure you, when we go through this process, you're going to understand what we're saying. So we're first talking about how angles relate to sides. I'll write the theorem out real quick, and then I'll show you what it looks like. I think most of this you can pretty much eyeball, you can pretty much predict. It's more or less giving you a reason why it is what it is. That way, if your drawing isn't to scale, you'll still be okay. So, if two sides of a triangle are not congruent. Now, we just say that because if they're congruent, then that means something completely different about the angles, but I think you already know that. If two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. So again, I think this is pretty much common sense. We're just going to put a reason to it. Name the smallest and largest angles of the triangle. Now, you're probably looking at it, and the first thing that you're probably thinking is angle Z is the smallest. Guess what? You're right. This theorem is giving a reason why. The larger angle lies opposite the longer side. Now, if we switch that up, that means the smaller angle lies opposite the smaller side. So if you look at that particular triangle, whatever the smallest side is, you can go opposite that side to get the smallest angle. Which makes sense, because if you have an angle that's opening smaller, it's going to create a smaller opposite side. Okay, so that means the smallest angle would be angle Z. All right, then that means the largest one, well, if we were to take this same picture and we were to go to the largest side, which is the 8, that would be XZ, and then we would go opposite, that means the largest angle would have to be angle Y. All right, let's try again with the next one. The smallest side is RT. If you were to go opposite, you would end up pointing to angle S. All right, that means the largest side is 16. So if you want to know what the largest angle is, once again, you're going to point and you're going to go opposite, which would put you at angle T. All right, let's try this next one without actually pointing or drawing anything. Let's see if we've got this down. The smallest side is UV. If you were to draw an arrow opposite that, you would end up at angle W. The largest side is UW. If you were to draw an arrow pointing opposite, that would be angle V. All right, let's step it up a little bit. List the angles in order from smallest to largest. Okay, so now this time we have to list all three of them. So that would be angle K, because it is opposite the smallest side. Then we would go to angle M, because that's opposite the in-between side. And then last but not least, that would leave us with angle L. Angle L is the biggest angle because it is opposite the biggest side. 10 is the biggest side, so if we go opposite, we end up with L. All right, let's keep going here. You can even tell just by eyeballing this one. It's not even that hard to do, but angle B is definitely the smallest. Then angle D, because it is opposite the side of 8. And then last but not least, angle C, because it is opposite the side of 10. Let's try this one more time. We have angle C, that would be the smallest angle. You can tell just by looking at it, but it's good to double check your work and say, oh, well, the smallest side is 4. If I were to go opposite, that would get me to angle C. All right, the next smallest side is 7. If we were to go opposite that, we'd get to B. And then that means A is last. All right, if I'm moving too fast, pause it right here. And then when you're ready, unpause it and we'll go on to the next one. Take a couple seconds. All right, let's do this thing. Theorem 511. We've just got a couple more theorems to go. And this is more or less the opposite idea. If two angles of a triangle are not congruent, then the longer side lies opposite the larger angle. Same idea. Now, in this particular case, you might have to do a little bit of extra work. Name the shortest and longest sides of the triangle. Well, first, I have 35 degrees and 65 degrees. That adds up to 100, which means I have 80 degrees left over. Now that I know that, I can cut to the chase here. The shortest side in the picture is opposite the shorter angle because the longer side lies opposite the larger angle. So that would mean PQ would have to be the shortest side. The longest side lies opposite the largest angle, which would have to be RQ or QR. It doesn't really matter. It makes no difference. You can write either one. All right, once again, we have a little extra work to do on this one. We have a 45 and a 60. That adds up to 105. So we have to first figure out that there are 75 degrees left. We're just taking away from 180 until we get what we want. The shortest side is going to be the one opposite the 45-degree angle, which is MN. And again, you could draw an arrow if you wanted to. It always works in opposites. Everything we do today is just sort of an opposites game. The longest is going to be opposite the largest angle, which is going to be NL or LN. It doesn't really matter what order you put it in as long as you use a good symbol. All right, then you go over here. We have a 90 and a 55. I'm not going to go over the math there. Once again, we're just subtracting from 180 to figure out what the leftover angle is going to be. The shortest one is going to be opposite the smallest angle, so that's going to be AB. Then the largest one, well, it's a right triangle, so the longest side is obviously going to be the hypotenuse. It always is. Hopefully you feel pretty comfortable with that by now. All right, list the sides in order from shortest to longest. So we're going to have to list them off 1, 2, 3 this time. So why don't we get the math going on all three of these? I'm going to just take away from 180 over and over and over again so that we're ready to do the actual hard part. This last example, we have 92 plus 43 is 135. That leaves us with 45 degrees left. This one was almost a right triangle, just not quite. All right, so basically, if you want to go through this and you want to do it quickly, you always just go opposite the smallest angle to get to the shortest side. And then you keep going, and then you keep going over and over and over again every single time. So in this case, the first one I'm pointing to is DF. Then the next one I pointed to was EF, and then DE. Make sure you put the line symbols over each one. All right, we go over here. The smallest angle is 53. If we were to go opposite, that would put me at HJ. So that should hopefully get us started. We have HJ. Then after that, 56 degrees would point to HI. And then last but not least would be IJ. Make sure you put your segment symbols over it so that we're naming these correctly. Last but not least, if the smallest angle is 43, then that means PQ is the smallest side. Then we go to OP, and then we go to OQ. All right, so once again, hopefully you're feeling pretty good about that. You can pause it if you need to jot that down really quick. We've got one last quick part to talk about here. All right, the last theorem that we're talking about is the T-Rex Theorem. That is not actually the name of it. That is the name that I give it because that's what it reminds me of. And it says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. All right, so here's the long story short. And there's not a great place on your paper to draw this, so I'm just going to demonstrate. Let's say I told you that one side of a triangle was 4, and then I told you that another side of a triangle was 7, but then I told you the third side of the triangle was, let's say, 15. The 4 and the 7 are not long enough to actually make it across each other to the point where they touch. I always call this the T-Rex theorem because if you look, here's the cheesy little meme that I found about it. If you're happy and you know it, clap your, because T-Rex, it's got short arms. That's the idea. If your arms are too short, you can't make a triangle. So essentially, if you want this thing to make a triangle, these two have to be greater than the third. So there's a little drawing that you could use to visualize it. We've got the cheesy meme. Let's cut to the chase. Circle the side lengths that can produce triangles. Well, is 3 plus 4 greater than 5? Are the 3 and 4 long enough to reach across the 5? Absolutely. That means these could make a triangle. In fact, it's a right triangle, but we won't get into that right this second. All right, 4, 8, and 13. Is the 4 and the 8 long enough to make it across the 13? So you've got 4 plus 8 is greater than 13. That's not true. There is no way. 4 plus 8 is not greater than 13. It's less than 13. So that is a no. All right, 9, 9, 9. A lot of people think that this is a trick question. They're like, oh, well, that can't make a triangle. Is 9 plus 9 greater than 9? Well, since 9 plus 9 is 18, pretty sure that checks out. And you can probably tell, if you actually stop and think about it for a second, that would be an equilateral triangle, which is totally fine. 4, 6, 2. Now, these numbers are out of order a little bit. So we probably need to take a quick look here and rearrange them, 2, 4, 6 instead. And then we ask ourselves, is 2 plus 4 greater than 6? 2 plus 4 is equal to 6, but it is not greater than 6, which means if we actually tried to design a triangle using A2, A4, and a 6, the only way they would ever touch in the end would be if they dropped all the way down and became one straight line. So you think it's going to work because, oh, they equal 6, but that's not good enough. In order for it to actually work, it actually has to be greater than 6, which is why this one would be a no, that you could not make a triangle out of that. All right, thanks for watching. I'll see you next time.